Okay, we're going to be looking at a new transformation of graphs. This is going to be trig graphs part 3, and this stuff is called a phase shift, which I'll explain what that means in a second. Okay, now the first thing that we're going to look at is just the sine x curve. That's that one, and the cos x curve. So remember that the sine x curve has got this kind of snake type shape. Cos x curve is more of a U shape. Okay, so some key points is with the sine x curve, it starts at 0, and then when you get along to 90, it's up to 1, back to 0, 180, along to 270, minus 1, and back to 0, 360. And this one, cos x, is up at 1, at 0, along to 90, you're down to 0, down to minus 1 when you get along to 180, along to 270, you're back up at 0, and then when you get to 360, you're back up at 1. Okay, now this thing that we're looking at today is called a phase shift. Okay, so let's take this down just now. Let's say we had sine x plus 30. Okay, so we would call that there a phase shift of 30. Okay, now what a phase shift means is that you move the curve horizontally. And in this case, it's by 30 degrees. Now, the plus might make you think that you move the thing in the positive direction, so that would be to the right, but actually you think counterintuitively with that one, and if it's plus 30, you actually move the thing to the left. Okay, so that would be, plus 30 would be horizontally by 30 degrees to the left. Okay, now if you had, for example, y equals sine x minus 40, then again it's a horizontal shift if it's inside the bracket. So that's the thing that we call the phase shift, is when it's inside the bracket. So minus 40, again that might make you think that you would go 40 degrees in the negative direction, but you don't, you actually go 40 degrees in the positive direction, so that would be 40 degrees to the right. Now what we're going to do now is look at where this could come up, and what we need to do is identify the phase shift for each question. Okay, so here's the first question. We've got a sine curve, and we need to find the value of b. Now the key point that we've got in the curve is this bit 20. Now you can see that the bit where the curve climbs off the x-axis, which is what's doing there, that normally happens at 0. So that's now been shifted to 20. Now, obviously then that is 20 degrees to the right. So 20 degrees to the right means that b must be equal to minus 20, because remember that you think counterintuitively that one, right? If it moves to the right, then it's negative, but if it moves to the left, then that's positive. So we can see that it should climb from 0 off the x-axis, but it climbs off the x-axis at 20, so that's 20 degrees to the right, and that means that's minus 20. Okay, so here's the next one. Right, so this time it climbs from the x-axis at minus 30, but it should climb from the x-axis at 0. So that means the thing has been moved 30 degrees to the left. Okay, so this means it's been moved in the negative direction by 30 degrees. Therefore, you think counterintuitively then, so it wouldn't be minus 30 for b, it would be plus 30. Okay, the next one. So again, it's sine x plus b, and I need to find b again. What's this curve I'm looking at this time? Okay. You can see that there's no numbers here and here, but I do have a number here. So when does the curve normally end? When does it normally climb back up to the x-axis? It normally does that at 360. but it's doing it at 320. That means it's been pulled back. It's been pulled to the left by 40 degrees. So it's been pulled in the negative direction, which means if it's been pulled in the negative direction, B is plus 40. So it's looking for these anchor points here of either 0, 90, 180, 200, 360. So in the last couple of examples, I had the numbers here and over there, but this time it's 320. So that's, look at the shape, where does it normally end and go back to the x-axis? It normally does that at 360. It's doing it at 320, which means it's been pulled to the left by 40 degrees. It's been pulled in the negative direction by 40 degrees, which means B is positive 40, because you think the opposite with that one. Okay, next one. I can see that the curve ends at 410. So again, I have to find the value of B, the phase shift, that's the horizontal shift. The curve finishes at 410. Well, the curve should normally finish at 360. Okay, if it finishes at 410, that means 360 has been pulled 50 degrees in the positive direction, so 50 degrees to the right, which means B must be minus 50 because you put down the opposite. Okay, this time we're looking at a cosine curve, so let's focus on cos x. Okay, so if you think about this as almost as if it's the top of a roller coaster and it goes down and back up to the finish, so it normally finishes at 360 degrees, but we can see that it finishes at 400 degrees, which means it's been pulled to the right by 40 degrees, it's been pulled in the positive direction by 40 degrees, so that must be B equals minus 40, so remember if it's to the right it's negative and to the left it's positive. Okay, next one. Okay, so we can see that the curve finishes at 320, but the curve should finish at 360, so that means it's been pulled back, it's been pulled to the left from 360 to 320, so it's been pulled to the left by 40 degrees, that's in the negative direction by 40 degrees, which means B is plus 40. Okay, so the curve should start and drop at 0. We can see that it starts and drops at minus 47. That means it's been pulled back by 47, pulled to the left by 47, so that's B equals positive 47. So remember, to the right, negative, to the left, positive. Okay, look at this one up here. So we can see the curve finishes at 345 degrees, it's cos, so I'm looking at the cos curve. Okay, so the cos curve should finish at 360, but it's finishing at 345, which means it's been pulled back, it's been pulled to the left in the negative direction by 15 degrees. So if it's in the negative direction by 15 degrees, it must be plus 15 degrees. Okay, so here's 6 to try. The first three, this one, and this one, are sine curves. Okay, and remember that the sine curve should start to climb from 0 and finish off at 360. So that one is in reference to that curve, that one, and this one. So we can see this one starts at minus 40, starts at 25, ends at 290. So for each one, for questions 1, 2 and 3, those are sine curves, and you need to find the value of B. The 4th, 5th and 6th one are cosine curves, so you should be looking at here as a reference. We can see that the sine curve starts to drop from 0 and finishes back up the top at 360. We've got a finishing point here of 400, 342 and 376. So for first 3 questions it's sine, next 3 questions it's cos, and in each one you need to find the value of B. So have a go at them for next day.